3D printing, also known as additive manufacturing. So basically what's going on here is you have this nozzle, this heated nozzle that is going to follow the computer's digital instructions to print or more accurately manufacture a part. The best way to think about it is a hot glue gun that's precisely controlled by motors to move to very specific locations and then heat the plastic to then redeposit it, so you get this sort of molten semi-liquid consistency that gets deposited in very specific areas and builds apart layer by layer. Here's a quick video of a time lapse I made just to kind of show you how this looks. So the neat thing here is we're actually printing a nut and bolt, and you can actually print threads that work with a 3D printer, and these actually work really well. All right, let's talk about the workflow. You're going to need to start with a 3D model. A lot of times I get people asking me, or they'll come in with a picture, just a hand-drawn 2D picture, and they'll say, I want to 3D print this. And you can't really turn a 2D image into a 3D model. Some steps you got to go through first. But the basic idea, the workflow, is you start with a 3D model, and you take that 3D model and you have to export it as either an STL file or a 3MF. There are a few other file formats, but these are the two most commonly used, with STL files still being the most prominent. So STL or 3MF file, you get that and you import it into a software that's referred to as a slicer. Now there are a variety of software that does this, but in general we refer to them as the slicer. Now the slicer takes that STL file or 3MF file and converts it into what's called a G-code file. And a G-code file is simply numerical values that the 3D printer uses to tell the motors where to turn, how far to turn, how fast to move in order to go to the correct position, and how much plastic to extrude in order to create the part. So 3D model, you go to an STL or 3MF file, then you take that file into what's called a slicer. You slice that into G-code, the G-code being the final file format that goes into the 3D printer. So let's go back to that first step, 3D model. How do you get your 3D model? Well, there's three different ways to get a 3D model. You can design your own using a 3D design software. This is commonly referred to as a CAD software or a computer-aided design software. You can download one from the internet. There are multiple sites, which I'll show in a few minutes, that you can just go on, and they're community sites where people upload designs, and you can go ahead and download a model and print that. You can scan your model with a 3D scanner, or you can even use a digital camera to take a bunch of pictures and then stitch those pictures into a 3D model. And there are several phone applications that can do this. Okay, let's start with that first method of getting your 3D model, and the most powerful, and that's being able to create your own. The great thing that happened when 3D printers started to make its way into the consumer level is that you began to see affordable and even a lot of very free and powerful design software. I've got a few listed here that you can start with. Fusion 360 is a very powerful, and they have a free license. For one, there's also a professional and a startup license. A few more include SketchUp, Tinkercad, Onshape, Shaper 3D, and you have your sort of paid industry standards, just a few of them here: AutoCAD, SolidWorks, Rhino, Inventor. Okay, you've created your 3D model. Now you have to export it into a format that you can bring it into a slicer. Now, all CAD software have the ability to export models in either STLs or 3MF files, which are the main two formats you're going to use to be able to export it into a slicer. So you'll export it into one of those formats, and you're going to bring it into a slicer. And the slicer, as the picture kind of shows here, it takes your model and it basically slices it horizontally into a number of layers. And so when this file gets sent to the 3D printer, it's sending it one layer at a time. Now there are a bunch of different slicers that you can use. Usually that's determined by the type of printer you're using. Normally you'll want to use the slicer associated with the printer you have, although that's not always the case. But the nice thing about slicers is that they're mostly all free. In the makerspace, we currently have the Bamboo Studio slicer, but we've also have had the Prusa slicer, just a general slicer, as both of these are based off. Cura, Simplify 3D. All these are great slicers, and once you learn how to use one, it's very easy to navigate from one to the other. Okay, let's talk about the material we use for 3D printing. So this is referred to as filament. And there are a bunch of different varieties of filament. You can use different types of chemistry. I've listed the most common ones here, but if you're starting with 3D printing, I highly recommend that you first master PLA. PLA stands for polylactic acid. It's the most forgiving type of filament. It's just the most friendly to use. So you definitely want to start with PLA before you go on to any of the other ones here. You'll get to know which filaments are more appropriate for the type of application you're using. For quick prototyping, definitely PLA. If you're looking for something that needs to withstand maybe a little more heat, you can go with PETG or ABS. PETG will offer you a lot of the strengths of ABS, but a lot less finicky to work with. Nylon is one that's very finicky to work with, very prone to moisture. And then you've got your flexible filaments like TPU, and then composites, which are a mixture of two different materials. A common one is wood fill, which combines actual wood particles with PLA. Copper fill and bronze fill are other composites that will combine copper filings or bronze, for example, with different plastics. When you bring your model into your slicer, you're going to want to tell it what type of filament you're using because this is what the slicer is going to use to determine the settings, such as temperature and speed of printing. And within the Bambu slicer, you'll see here that we have 4 different slots of filament within our AMS unit. And here what you would do is just choose your slot and tell it which material you're using. So in this case, we've got a couple slots filled with PLA, one that says generic, one that has a specific brand of PLA, and then PETG and ABS. All right, let's talk about quality. When we talk about quality with 3D printing, we're referring to the vertical resolution or the layer height. Similar to the pixels in a digital image, the more layers you have, the higher quality you're going to get. The thinner the layer, the more layers you're going to get per millimeter, and the smoother the object will be. The normal resolution you're going to be dealing with are 0.1 to 0.3 millimeters. Now, there are cases where you can go higher resolution than that. For example, slicers will normally give you the option to go as high as a resolution as 0.05 millimeters. And if you're using a bigger nozzle, you may want to go with a lower resolution than 0.3. So that would be like a higher layer height than that. But normally you're going to be within these ranges here, 0.1 to 0.3, especially if you're using the default nozzle size, which is a 0.4 millimeter nozzle. Now you can take a look at the picture here and you see the difference between 0.1 and 0.3 millimeter layer height. The robot on the right here is 0.1 millimeters and you could barely see the layer lines, 0.2 in the middle and 0.3 here on the left, which you can see very prominently how the different, sort of the stepping of the layers there. So the important thing to remember here is the compromise, which is going to be a compromise between speed and quality. Comparing just the two here, let's say the robot here in the middle took you an hour to print at 0.2 millimeter layer height. Well, then you're looking at pretty much doubling that time if you're going to double the amount of layers, right? So you're going to go from 1 hour to 2 hours to print this. So just remember there, the compromise is speed versus time. Now, normally I'd say about 90% of things I print are at 0.2 millimeters layer height, and that's a nice compromise with speed and quality. If I'm printing something that is mainly straight walls, maybe a bracket, I'm going to go at 0.3 as I don't need that type of resolution. If I'm printing something that's very organic and I need a lot of features to show, then I may go at 0.1. If we look at the slicer really quick here, we're using Bambu Studio. And you've got a few presets here that you can choose. So if you just click on this little down arrow here, you can choose some presets. And here you can see that I have set it as 0.2 millimeter standard. And if I zoom into that part, you can see here that within the quality tab, there I have the option of choosing that resolution. You can also manually type it in here on the right. All right, let's talk about infill. When it comes to 3D printing a part, the part is rarely ever solid. You are always going to have a pattern on the inside that you can tell the slicer how dense to make it. Here's an example of what that looks like. And if I go to the next slide, you'll see what different infills would look like. So on the left here on the top, we've got 5% infill. and then you can see what 10%, 20%, and 40% infill looks like. Normally I'm staying between the 10 and 20% infill, but you'll quickly reach a point of diminishing returns where you're just wasting time in material. So most things, like I said, I'm between 10 and 20% infill. Very rarely will I go up to 30 or 40% infill. And you can see here that just a 40% infill is already getting very dense. Now if I wanted to print a part and have it be hollow in the inside, I would set the infill to 0. At this point, I'll pass around the model showing what different infill types look like. And in the slicer, you're going to go to the Strength tab, and the third item down here, you're going to see infill. And you can go ahead and change that percentage just by changing the number here. On the bottom where it says Grid, those are different infill patterns that you can choose. All right, let's talk about supports a bit. So the main thing to remember with 3D printing is you can't print on thin air. So if we look at this dog, for example, printing the feet, front and back feet here will be fine. It'll continue going up. However, when it gets to the stomach here, it's going to have issues because there's nothing supporting it. And in this case, reorienting the part really wouldn't help with not needing supports. So we are left with our only option, which is to go ahead and enable supports. When you enable supports, it creates these vertical columns that will help support the part of the print so that it's not just printing in thin air and will fail. When deciding if your part is going to need supports, it's important to keep in mind the YHT rule. The Y demonstrates the ability of the printer to print at an angle without needing supports. Now, at a 45 degrees, you're okay, something like this. But as this arm here gets shallower and shallower, then it starts to become a problem. The H represents the printer's ability to bridge. So if you have two columns on each side, you can actually bridge the gap in between. The printer is capable of extruding filament that can start on one column and attach to the other while maintaining a certain distance without collapsing. This only works where there's a starting and an end column where it can attach to, and also if the distance is not too large. And different printers will have different capabilities on how far they can bridge. Now the T represents a failure here. So we can see as we go up, the center column is fine, but as we start extending out to the top bar here, you can see that there's quite a bit of failure here where the printer was pretty much printing on thin air. Now it'll eventually begin to recover, but this is a lot of work to clean up. Now to solve this problem, you may automatically think, well, let's just enable supports, which would work. It would create these vertical columns that would support the horizontal bar here, which you can just snap off later. However, the T is a perfect example of thinking about ways to reorient your part in order to not need supports. So you want to get into the habit of not always relying on supports. And with this T, there's a few ways you can approach it. You can either lay it flat here, like turning it upside down and allow it to lay flat on this side, or you can just lay it flat on its side. Say if I push the T back and it's just flat that way. So you've got options before you resort to supports. Because supports takes time and it uses more material, so if you don't have to use it, don't. Here we see an example of why the Y works, the letter Y. So when you're printing at an angle, if we look at these as individual layers, you see that the printer has the ability to overhang slightly as it goes from one layer to the other. Normally, if you've got a 45-degree angle, as you see measured here, your printer will do fine. Most printers can handle that, and even the newer printers can go as high as 50, 60 degrees. The picture on the right shows what happens when you have an overhang. So here we have a 90-degree overhang, and obviously there's nothing to support this overhang, so this would result in a print failure. In order to enable supports in Bambu Studio, simply go to the Support tab and click the little check mark here where it says Enable Support.